Good morning, doctors. So this is our group member from the section 2 group what consists of John Carlo, Obekias, Naziha, Alif Aimas, and Adam Raimi. Even though we are not discuss who is the leader, but we all believe that Lord will be our spiritual leader. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Raimi bin Kanu Azmi. My matrix number is AE220029 and I will be presenting for the introduction, objective and conclusion. So for the introduction, the key concept and implementation is that digitalization is the process of converting analog information into digital form. It plays an important role in making processes more efficient, agile, and easier to manage in different fields like engineering, education, and businesses. At the core of digitalization is digital signal processing, or DSP. DSP allows us to analyze, stimulate, and store various types of signals such as audio, video, and sensor data. In the software implementation, we use MATLAB to perform signal addition. We also verify the result with manual calculation to ensure accuracy. For the hardware implementation, we use Tinkercad to stimulate the algorithm. This allowed us to test digital logic and hardware interaction using virtual components. Together, these methods show how DSP can be applied both in software and hardware environments to support digitalization.
Next is literature review. So A. Introduction to Digital Processing. Digital Signal Processing (DSP) is widely used in various devices such as smartphones, music players, and medical equipment. DSP processes signals that are captured from the real world and converted into a digital form that computers can understand. One of the most fundamental operations in DSP is adding two signals together. This basic operation serves as a building block for more complex signal processing tasks. B. Understanding signal addition. When we add two digital signals, we are simply combining their numerical values point by point. For example, if signal A has values 132 and signal B has values 213, the sum would be 345. C. Practical applications. Basic steps for adding signals in MATLAB are: create or import the signals to be added, use simple addition operations, and plot the results to visualize the outcome. After testing in MATLAB, the same addition algorithm was implemented using hardware. According to the Lightning Chat article, many real-world DSP systems simulate algorithms in MATLAB first. This approach helps catch problems early and save development time. Next is problem statement. Digital signal processing is used to analyze and modify digital signals. These algorithms are used on software platforms such as Tinkercad and MATLAB, while for the hardware platform is Arduino Uno. The problem are students understand theory but struggle with real implementation, and simulation tools also have limitations in accuracy and control.
For the objective part, to understand the fundamental concept and principle of digital signal processing by signal addition. Second, to design a DSP-based addition algorithm system that can sum two different digital signals. Third, to implement the developed DSP addition algorithm on hardware using an Arduino Uno board for real-time signal processing. And lastly, to compare the outputs obtained from the MATLAB and the Arduino Uno board and verify them against the theoretical values. Okay, for the methodology part, the goal of the study is to compare how basic DSP operation perform using three methods, which is manual calculation, MATLAB software, and Arduino hardware. A. Signal generation. We have two signal, which is signal A. The value is 11001, and signal B, the value is 01101. These signals are used for all three methods. B. For the manual calculation, signal A and B were added manually, step by step. Result were recorded in a table. This served as the theoretical reference. Okay, C. MATLAB software implementation. A simple MATLAB code was written to add two signals, provides quick and accurate software-based solution. And D. Arduino Uno R3 using Tinkercad simulation. The Arduino code was written to add two signals. Results were displayed on an LCD screen. E. The simulation and result discussion. All results, manual, MATLAB and Arduino, were collected in two comparison tables. The results were analyzed for accuracy.
So the first one is the manual calculation. We want to compare the value between the manual calculations, simulations, and in the real life applications. So we took the easiest algorithm, which is the addition, to see the result. In this case, we just simply adding the two signals, the value of two signals, and get 12102. In this part, we are doing the implementations of DSP addition algorithm in MATLAB, which is the simulation. We first define the values of two signals into the MATLAB, and then using the addition algorithm, which is the sum, to add on these two signal. Then the code from the middle to below shows how we display the output and make a graph. And we can see from the right side of the picture, we will get the same result as our manual calculation. So we can say this is a valid answer because it's consistent from the beginning to the middle and will be continued to the end.
Okay, so my name is Rowicat, metric number AE220058. So now I'm presenting about the coding we wrote in the Arduino IDE. Okay, first we define the input signal A and B, and also the range for our output signal C. Okay, and then first we ask the LCD screen to show the word simple addition calculator. Okay, and then it will perform the simple addition function where the input signal A and B will be added together to produce the signal C. Then lastly, the LCD will display the output signal for the signal C. So next we move on to the data analysis and discussion part, and then we collected all the data and tabulated in a table, and it showed that uh, they show the almost similar output result for the output signal C, regardless of which method you use. Okay, but actually MATLAB and Arduino right, can work faster than the manual calculation. And MATLAB can provide a better visualization because it can provide a graph, right, for us to understand the output signal clearly. And then Arduino is suitable for the real-time display.
For the conclusion, to conclude, the DSP addition algorithm was tested using three different methods, that is, manual calculation, MATLAB, and Arduino using Tinkercad. All of these methods give the same correct output, which proves that the algorithm works accurately across platforms. The manual method is great for understanding the concept, but it is slow and not suitable for large datasets. MATLAB is faster and allows us to plot and visualize the signals, making it the best tool for analysis and learning. For Arduino, on the other hand, it is suitable for real-time processing in hardware, though it has limited display features. So the best method depends on what your need is. Use manual calculation for learning, MATLAB for analysis, and Arduino for real-time application. That's all from me. Thank you.